All right, so this is my second video on chapter 6, and on this I'm going to talk about graphing, and I'm going to talk about domain and range. So I have this example here, y equals the square root of x plus 2, and graphing is kind of a visual idea, and domain and range may or may not be a visual idea. And when I made my list of ways to understand a function, it's kind of unclear which one comes first, the graphing or the domain and range. I mean, they kind of fit together, so it's hard to talk about one without talking about the other. All right, so let's talk about the domain first. So I can find the domain in a very kind of formulaic way, and now this formula only works for certain functions, and I mean for, well, very few functions, but argument greater than 0 is essentially the formula to find the domain of square root. In other words, we know that square root works if the argument is greater than or equal to 0. So that means I want to solve this. X plus 2 is greater than or equal to 0, and I get x is greater than or equal to -2. So this is the domain. I could write it, just go straight into interval notation here. The minimum is -2, and the maximum is infinity. So remember, minimum comma maximum whenever you're talking about an interval. All right, that's the domain. I'll talk about the range in a moment, but the domain all kind of came out of this fact that the argument has to be greater than 0. All right, now you know that word argument by now. I use it in almost every video, I think. Books will call it, I think the author calls it the radicand, which is true. It is the radicand, but there are so many times I can use the word argument. I just kind of prefer using that. All right, now here's where you got to be really good at square roots numerically. I guess you don't have to be good. You could kind of just guess your way through this, but I've said this before. You pick your x values, and let me go ahead and do that. I'm going to pick -2, -1, 2, and let's see, I want that to be 9 and 5. No, 7. I couldn't see what I was writing, but that's not a good excuse. All right. I picked those values. Now, why would I pick those values? Well, because I understand the square root function numerically. In other words, you have no business doing this if you don't understand the square root function numerically. All right. So, for example, why the 7? Well, do you see that when x is 7, I'm taking the square root of 9? And that's one of my favorite numbers, the square root of 9, because it's one of the perfect squares. Well, if I put in a 9, I get a 3. In other words, if I put a 7 in here, I had to think about it for a second, but shouldn't be more than a second. If I put a 7 here, 7, 8, 9, square root of 9 is 3. Why did I pick 2? Because 2 makes the argument 2 plus 2, which is 4, and the square root of 4 is 2. Why did I pick -1? Because -1 plus 2 is 1, and the square root of 1 is 1. And of course, -2. Now, -2, I picked it because it's the first value in my range, in my domain, rather. But also, hopefully you can see it. If I put in a -2 plus 2, that's 0, and the square root of 0 is 0. So these are my ordered pairs, and I'm going to plot those. Let's call this one A, B, C, and D. Right, my hand got in the way. There's where I'm going to plot point A. Here's where I'm going to plot point B. Point C, 2, 2. I don't know if you see it, but there are little dots here, so I don't have the grid marked, but that is the second dot over. Okay, so that's point C. 2, comma 2 as an ordered pair, and 7, comma 3. So 1, 2, 3, 4, 5, 6, 7, 3. Here's my point D. All right. Now, the only thing left here is you should know the shape of this graph. And you do. There aren't that many shapes in an algebra class. But one shape that we saw in chapter 2 was the parabola. It's a pretty bad parabola, but a parabola. Now, what would happen if I cut a parabola in half? I'd have half of a parabola. Now, what if I turn that parabola on its side? Well, I'd have the shape of the square root function. All right. So square root function is just half a parabola. So that shape going through these points, I don't want to continue the shape and make a parabola. I just want to draw that shape. All right. So hopefully you followed what I did there, but there's still one more mystery I haven't, or one more question I haven't answered here. I answered the domain, -2 to infinity. I gave you the graph, but what about the range? All right, now I like to think about it this way. If I were to mark this -1, -2, if I were to mark the y-axis, of course this way, 1, 2, 3, all right. Do you understand that I don't really need to mark the -2 because there's no graph there, or the -1 because there's no graph there? Where would I mark the y-axis if I had to mark the graph just where the graph exists? Well, it would be right here at 0, right? Because there is a point where y equals 0. I mean, I have it up here, -2, comma 0, right? So 0 is the minimum y value. The maximum y value, well, the maximum y value, this graph just keeps on getting wider and wider and wider, so we'd have to say infinity. So when I'm looking for the range, that's probably the best way to ask yourself, what is the range? Think about the minimum and the maximum. The minimum is 0, maximum is negative or positive infinity, and you can just see that from the picture. So in a lot of cases, you can find the graph, you can find the domain, but the range is kind of the last question you answer because you want to look at it visually. And just look at what part of the y-axis the graph would kind of take up. All right, so that was a fairly quick video on that idea, but I will say it's an important idea only because it's one of those things that you probably did not master in your, I don't know, 12-year history with radicals. You've certainly talked about square roots of numbers. You might have used a calculator to take the square root of some exotic number. I don't know, got some long decimal. Sure, you've done things with square roots for a very long time, but I like to put it this way: if your 10-year-old nephew came up to you and said, you know, with his first calculator and said, "Hey, ask me a question about square roots," you wouldn't say, "Okay, graph y equals the square root of x plus 2." This is one of those things that just is not part of the human experience until you get into a class as advanced as this one. So that's the only reason why I think that it's you know, a bit of a challenge. Is just is not as familiar to us as so many other things about about square roots. All right, so this video was domain, range, and the graph of a radical function.